Yeah, so let's see the third core image, which is kernel dev. So, as per the name, it clearly means that those who are working with kernel development and those who want to uh, build kernel recipes or module on the target itself, those people can build this image and try to deploy it and see what it has to offer. So similarly, like I did in my previous videos, I have made the environment file for kernel development and I'm going to compare it with core image minimal. So as you can see, for all the core image recipes, the features list is same. Here the kernel modules is added extra, but already it is a part of it, so it will remove the extra thing or whatever is there as a duplicate. Now here you can see one new portion is added. So what it says that there are some test suites that are added in kernel development image and that are ping, SSH, conman, syslaw. So this type of testing will be performed on the image, and the same packages will be available as a part of the image. So it will be present in your rootfs. So you can also perform these tests. So these are to check your connections, uh, Ethernet or Wi-Fi connections, or some SCP is also there, so that you can check your copying permission as well. So now let's see the description of this image. It says that development image that builds the kernel and the packages that are sensitive to kernel updates and version changes. So as the name suggests, it is there for the kernel development itself. And you will see in features install, there is a new package group added, which is tools profile. So profiling tools will be added as a part of this image. So let's see what are these profiling tools and what it contains. So here, this is the recipe of this profiling tool. So as we all know that perf is a kind of profiling tool. So perf is added. Power top is also added. So Valgrind is also one kind of tool they are adding as a part of profiling. So just focus on this. Whatever is there in RDepends, that will be a part of your rootfs. So in RDepends, the first is profiling tools, then LTT English, Valgrind. This type of tools are added. So you can see the reference, the what LTTNG tools are there. System tab, POF, Valgrind, PowerTop, and if your distro feature contains the systemd, it will have the systemd analyzer. So all kind of profiling tools are added as a part of this package group. So that is something new in your kernel development image. So as you see, whatever is added as a part of package group, that is added here in image features. The tool profile is nothing but the package group profiling tools. Furthermore, as you can see, the rootfs extra space has one new value now, as there are a number of tools and source codes will be part of your image. So it has increased the rootfs size. Now which file is doing that, that is also available here. So here in the comment section you can see that the kernel development bb file itself is adding this extra information. Now here also one more new portion is added. You see the kernel development module, and there are some tools are added. First is whatever we saw, tools profile. Furthermore, build essential is also added. As you all know that building the kernel will require to install this build essential. So in Ubuntu, it can be simply installed using apt-get install build essential. Here we have a separate recipe for that. So let's see how many tools it contains. So as you can see, the auto tools are part of this build essential. Apart from that, tool chain G++ is also there, GCC is there, get text, make, pkg config. So all these are part of your build essential package group. So this all will be installed, and it will be shipped with your rootfs. Furthermore, here you can see the conman is also added. Those who don't know what is conman, it is a daemon for managing internet connections within embedded devices. So this is the recipe which provides that feature. It will be bundled as a package in your rootfs. So now whatever internet connections you have on your board, let's suppose Wi-Fi is there, or for Bluetooth, BlueZ is there. So in distro features, you can add Wi-Fi or BlueZ, and your conman will have this configuration while building the image. It also has some init scripts for systemd. So automatically while booting, it will load all your services, and automatically it will start running the daemon backend. Till now, we are not encountering any difference. Let's see. Yeah, so that is the all the difference we can find with this diffconf. Yeah, as you can see in our depends, there is one more package is added, kernel dev source. So let's see what it will do. Yeah, here is the recipe. So whatever development source code we have, or whatever Linux kernel we are going to put in our rootfs, so the source code of that Linux kernel will be shipped as a part of your rootfs. And as we all know that in local.conf we specify, or any distro configuration we specify the preferred virtual kernel. So whatever kernel we want to be a part of our rootfs, so that kernel source code will be picked and will be put in our rootfs. So as you can see, it has a lot of uh, do install lines, which will first check which Linux kernel or image is pointing to. It will look at the work directory of the Linux kernel, and it will bundle it as a package, and then while creating the rootfs it will install it. So this is what it does. So I think now uh, this is all we can see in the kernel development image. So this also can be tried. You can build it for a camo x86 and see what extra things you can find in that.